Hi class, it's Professor Nick Sensky at UNC Charlotte. This is part 2 of the lecture 3 demonstrations talking about panelizing surfaces. And this is really going to be sort of basic, but hopefully it'll give you the tools you need to look at your assignment this week and begin thinking about how you can panelize something for your daylight study project. So there are lots of different ways to start with a surface or to obtain a surface. If you look at the surface tools in Rhino, you can draw a surface as a rectangular plane. You can do a rail surface if you have cross sections in a rail. You could do a surface if you have the edges of things. You could loft something. You could extrude something. Surface from points. There are lots of different ways to look at surfaces. So just something really basic. Like I'm gonna have a section. I'm gonna have a basic kind of flat surface, and you can think of that as a skylight or a piece of your facade. And I'm gonna do another surface that has a bit more interest, and just take a curve and make something kind of curvy and extrude it. For your project, I mean, you'll take a surface that you derive from your project, and so it'll be more meaningful than this, but this will be enough for our demonstration. So I've got a surface like that, and a basic kind of surface like this. Okay, so a really common pattern that we're going to be using over and over again is to divide a surface using a surface domain. So let's reference our surface. That. Then we're going to do divide domain squared. So you want to divide the surface into a two-dimensional domain. And you have u and v coordinates for that, and then you get a domain, which is just a series. It tells you where a curve begins and ends on the surface. And that's important, again, because we don't have x, y, z space here. We have u, v space. So you need a special kind of language to talk about curvature. So we're going to take that domain, and we're going to take what's called an iso trim, and we're going to put that in. And so this one wants a domain and a surface. So it's going to trim our surface according to some kind of domain. So take the surface, plug it in, take the domain, plug it in, and you can see that we've got a series of subdivisions. And then if you go in and you add sliders, whole numbers, and in this case, I'm going to make them relatively large. So U, V, you have to have more than one. So you can see if I have 8 divisions and I have 17 divisions. So I can parcel this up into different kinds of proportions. Okay, and what does that get us? Well, there's different ways of distributing geometry according to those divisions. Okay. And that's where it comes in handy. You can also use it to kind of create structural panels for things. So there's lots of uses for it. It's different than what I showed you before. If you looked at divide surface, this is one way of looking at it, and it gives us a series of points, but it gives us points on all the edges. And if you want to put something on a surface, or cut something out of a surface, or project something from a surface, those edge points aren't going to do us a whole lot of good. If you want to use the surface as a way to just distribute something, then maybe that's useful. So, but it's different than if we would take our surface here, and let's say take that surface, and then let's add area, and you can see that now we've got a point in the center of all these, and so they're not on the edges. They're actually inside of these kind of cells. Okay, so I just took an area component and plugged it in. And once you've got that, though, you can do interesting things. Like I could take a simple kind of circle, and I could distribute it to all those points. Now we got a problem, though. If you look at this, so we're in the ZX plane. Circles are in the XY plane. Okay. So what we need to do is we need to make a ZX or XZ plane, and then put the circles on it. So let's take the centroid, make that where the planes are drawn, and then let's draw circles on it. That's better. So again, you gotta respect the plane you're working in, and sometimes that means you have to actually just take a plane and like make it at a certain location. Sometimes you have to do things like find the normal of the surface if it has a curvature. We'll be looking at that, but planes are really important when you're working with surfaces. Okay, if something's kind of wacky, it's because it's probably not oriented to the plane properly. So we could go in, add a number slider for the radius. Let's turn off these so we can see. So we got circles, and you can create kind of a pattern for that. Okay, so really kind of basic and simple. You could go in and add a cull, and I could cull, every other one. That can become kind of interesting. Let me go ahead and add a slider for that. Let's examine that a bit. Whoops. So I have a cull slider, and so different kinds of distribution as I go. Some maybe more interesting than others, but get different stripes. That 5 is kind of neat. Look at that. 2, 4, 1, 3, 5, 4, 2. Nice. Okay, so that would be an interesting kind of pattern to look at, right? I think, and so you could do that. You could experiment by taking those circles and applying a random radius to them. So let's take, now we have to know how many there are. We have like 510. One easy way to do that is just take these two sliders and multiply them together. Oops. So 30 times 17, 510. Put that in for our number. And so we get pretty radically different set of circles. It's going to shrink this a bit, this domain. There we go. Don't want them to overlap those. And again, completely parametric. So I could always change that. And on Thursday we'll talk more about how to get logic into this. For now, it's a little dumb. We can kind of brute force some things with it, but it could be really interesting. So you take random. Let's try something else here. Let's do a range. Let's do a range from 0.1 to again 0.75. And let's plug in our number for that. And this is probably going to be, yeah. So they get roughly smaller and they get larger as they go. So again, that's an interesting kind of pattern that you could create, and it'd be very difficult to do this by hand. So lots of patterns for things. You could take and you could distribute some squares, and you could kind of rotate them, and that might be something to suggest some kind of windows. You could randomly rotate some squares. You could try other shapes if you want to. And again, you could always go in with some kind of cull pattern and do some really interesting stuff with that to create kind of stripes in your building. So all the things I talked about in distribution, apply to your surfaces when you've subdivided them. Okay, so kind of interesting what you can experiment with here. Yeah, interesting. Okay, so that's dealing with kind of a flat surface. The rules change slightly when you're dealing with a surface that has a curvature, particularly when it's in different planes. So what I've got is this surface that I made that has some curve. Okay, and the problem is that whenever I want to put some geometry on it, it's not going to adjust to the curvature unless I do a little bit of work. So let's take a look at what I mean by that, and let's see what we can do about getting some interesting geometry to map to this surface. Okay, so I'm gonna go ahead and turn this off. Maybe disable it. Okay, so I'm gonna start with this pattern here, which is just the stuff that we've been looking at. So I have a surface, it gets divided, and then we look at the divisions. So let's set this surface and let's take a look at what we've got. Yeah, so I've got a set of divisions in this surface that I can change like parametrically. Okay, and what I'm going to do with that is I want to distribute some circles to it. So take a circle, and the way I showed you was you go in and take area, and you get a nice happy center point. And if I apply my center point to the circles, it looks pretty good from up top. But if I go in, I have the same problem that I had before, where everything's just x, y, even if it's on those points. So what I need is a plane for each one of these that adjusts to the curvature. Okay, and we've talked about this before when we distributed geometry around that cone at the beginning during the lab for week 1. So we're going to do a similar thing. So we want a plane that has a normal that adjusts to the curvature. So we can go in to vector plane, so a plane normal. Okay, and those planes are what are going to go plug into our circles. That's the end result. Okay, but this wants a vector that's a normal, and so we need to get that from the surface. So we're going to go into analysis and evaluate the surface, and this will give us a normal. So plug that in. But this wants the UV coordinate on the surface. So we got to get that. Let's plug in the surface. We know that that's got to go in there. So we've got these points, but we want to associate them with a UV point, so a local coordinate point that's on the surface. Luckily, there's a tool that can do that. We have this thing that's called surface closest point, surface CP. So we take the surface, and we take a point, which are our center points, and that's going to return a UV coordinate for that point. And then the UV coordinate goes in to evaluate, and then we have our planes, and then we have our circles. Okay, and oh, except for we need to take the origin of the plane to be this point as well. So let's plug that in. Yeah, and if we turn some of that stuff off finally, turn preview off, you can see that these are actually adjusted now. Okay, and then we could go through and we could do things like changing the size of them, and with all kinds of logic. But for right now, let's just make them let's make them bigger. It's simple. So I have some circles, and I want to start to like perforate that surface. You might be tempted to make a Boolean or something. That's actually kind of hard to do. You could take these and extrude them. That's kind of what we have been talking about. But you can also punch them out. And I'm going to warn you, this is kind of intensive. Like this might slow your computer down, and it's not something that's going to be actively parametric because it takes so much computation to actually do the operation. So I would work at this level first until you want to begin to punch it out, and then you can do this. You're going to want to do a split surface, or surface split. So you take the surface, which is this guy, the original surface, and then take your curves, and then that's going to split. And this is the part that's going to take like a few seconds, because it's actually going to separate the surface from all of the points you made. And this is actually a bunch of surfaces. It's like 131 surfaces. All you want is the first surface in that list, because that's the one that got cut. So just do a list item, and we'll talk about this on next week. It's set up to take the first item in the index at 0. So if you just plug this into that list item, and then turn this off, like preview it, and then turn off your surface, you're actually going to get your surface. And again, I think I've said this a few times, but it's actually better than this. Like this is just the approximation of the whole. If I go through and I bake that item, the surface is perfectly fine. Like it's actually got rounded holes and stuff. Okay, so that's a technique for distributing some geometry, curves over a surface, and then you can apply different logic to them. We'll look at how to do that with an image on Thursday, but again, planes are really important when you're distributing geometry over a panelized surface, right? Panels have planes. I think that's a good thing to think about. Um, so from there, again, you could experiment with distributing different kinds of shapes, shapes that you draw yourself, more parametric shapes, applying logic to the shapes, applying culls to the shapes, uh, to get something that happens over a complex surface. Okay, that's the end of this part. I will see you in the next one.